So this is graphing exponential functions, part 72. It seems like because we dealt with this so many days. All right, graphing exponential functions. Okay, suppose I want to graph this function, f of x equal 1/4 to the x power. F of x equals 1/4 to the x power. And I want to compare it with g of x that, let's say, is 4 to the x power. So let's grab those two and compare them. I want you to notice the base, though. What do you notice about the base of each one? They're not the same, obviously, but what else can you say? They both contain 4s, but what I'm trying to get you to say is that 4, the one that has 4, that's an improper fraction. And the 1/4 is a proper fraction. Remember, an improper fraction is a number that's bigger than 1. A proper fraction is where the numerator is smaller than the denominator. So that's a number less than 1, right? Between 0 and 1? Something like that when you were just born.
That was a long time ago. I saw that, don't think I didn't see that.
So you're going to notice that when we graph these, the idea that the base is proper versus improper has something to do with what your function looks like. All right. So let's do the 4 to the x first. So let's graph g of x. So I'm going to use the bigger one, because I'm going to need those because these numbers for g of x will be big. So first of all, what is the horizontal asymptote for g of x? Y equals 4. Oh, y equals 4, you sure? Y equals 0. Or the x-axis, right? So I'm going to put a dotted line on the x-axis, just like this. Now remember, for these exponential functions, for this particular exponential function, or for any exponential function, will the graph ever cross the horizontal asymptote? No. So in this case, when I graph g of x, will it cross the horizontal asymptote? Will it cross the x-axis? No. All right, so we're graphing g of x equal 4 to the x. So we're graphing this exponential function. Basically, all you need are a couple of points and you're done. What should be one of them you will always find? The y-intercept, right? And to find the y-intercept, you're going to let x be 0. So you're going to notice that on the worksheet in my math lab, on your final, one of the things they're always going to ask you to find is the y-intercept, because every exponential function is going to have a y-intercept. And we talked about y a while back. It's going to have a y-intercept because what's the domain? Negative infinity to infinity. So x equals 0 is in the domain, right? So when x is 0, you're gonna have a y-intercept. So if x is 0, I get 4 to the 0, which we know is what? 1. So I'll plot the point 0, 1. If x is 2, I get 4 squared, which is 16. So 2, 16 is about here. Now let's do one more point. Let's do 1. If x, now I'm not going to do a 3 because it's going to be outside of my coordinate plane. But I can do a 1. If x is 1, I get 4 to the first power, which is what? 4. So 1/4 is here. And all you do is this. So now you know that on the right side of my y-intercept, my y values are increasing rapidly. Remember that phrase, increasing rapidly? And on the left side, your y values are getting smaller and smaller, but they're getting closer and closer to the what? X-axis. So it's kind of like your y values going to the left are decreasing, but not as much. And when going to the right, they're increasing rapidly. But remember, you always read a graph from left to right. So as I go from left to right, my y values are doing what? Increasing. All right. So one of the things you're going to be asked is this exponential function an increasing function or a decreasing function? It's increasing, because as you go from left to right, your y values are increasing. So at some point, it increases rapidly. Okay? And you're done. That's it. Now, you're also going to be asked this, though. So you will be asked, the horizontal asymptote, you're going to say what? Y equals 0. Domain, you're going to say what? In fact, for all exponential functions, what's the domain? Negative infinity. The range, now use the graph to help you with the range. What's the range? 0 to infinity. Is it bracket 0 or parentheses 0? Parentheses, because I can't use 0 for my y value. Because look, guys, is this y value ever going to be a 0? No, because it's not going to touch the x-axis. It gets closer and closer to it, but it's not going to touch it. So it's parentheses 0 to infinity. What's the y-intercept? They're going to ask you for that. As a point, you're going to say it's what? 0, 1. Okay? And is it increasing or decreasing? It's increasing. So it's an increasing function. Now let's look at f of x. Let's see what happens there. So f of x is 1/4 to the x power. So I'm going to try and use a different color here. All right. So again, when graph an exponential function, one of the points you're always going to use, one of the x values you're always going to use is 0. So if x is 0, what's 1/4 to the 0? 1. So I'll plot the point 0, 1, which is here, right here. Okay? Now, I want you to notice something. Your inclination is to use x equal 1. All right, let's use x equal 1. What is 1/4 to the first power? 1/4. So that's about 2, that is 2 point, I'm sorry, that is 0.25, right? So that's about 1/4 is about here. So you know what's happening to the right of this y-intercept. Your graph is doing what? It's getting closer and closer to the horizontal asymptote. So on the other side, so if I go to the left, it's going to be going up rapidly on this side, right? Okay? All right. So this time I'm going to let x be a negative number. Now you're going to need your calculator for this one. If x is -1, what is 1/4 to the -1 power? Use your calculator. Your calculator in parentheses, put in parentheses now. Parentheses, 1 divided by 4, close it, and raise it to the -1 power. What do you get? You get 4. Make sure all of you get 4. You get 4. So when x is -1, my y value is what? 4. If x is -2, what is 1/4 to the -2nd power? 16. So I get negative 2, 16. Which is here. And I just draw the graph like this. Do the best you can. And there's your graph. So this one here is f of x equal 1/4 to the x. So notice that for f of x, my function is increasing or decreasing? Decreasing. My function is decreasing. And also the horizontal asymptote is what? Y equals 0. The domain is what? Good. The range is, what's the range? 0 to infinity. What's the y-intercept? Okay, and it's a decreasing or increasing function? Decreasing. All right, I'm going to ask you this. In these particular cases, these two, what made one an increasing function? What made the other a decreasing function, do you think? The what? I prefer to use a better word. The base. The base. So if the base is bigger than 1, then you have what kind of function? Decreasing. Kind of makes sense because 2 to the second, 2 to the third, 2 to the fourth, 2 is bigger than 1, right? Those numbers getting bigger and bigger. Whereas 1/2 to the first is 1/2, 1/2 to the second is 0.25, 1/2 to the third is 1/8, whatever that may be. But those y values are decreasing. So it's your base. So if b is greater than 1, so if for f of x equal b to the x, if b is greater than 1, f of x is increasing. What made the other one decreasing? Okay, now, be a little bit careful with the phrase less than 1, because negative numbers are less than 1, right? But what do you remember about the base? It can never be negative. So in other words, it must be a positive number, right? Your base has to be positive, and it cannot be what positive number? 1. Very good. It cannot be 1. So rather than saying if b is less than 1, because b less than 1 meaning negative numbers, and your base can never be negative, we're going to say this instead. If b is between 1 and 0, meaning proper fraction between 0 and 1, not including 0 and not including what? 1. Then f of x is what? Decreasing. Okay? All right. Now, let's look at this. What if I wanted to graph? What if I wanted to graph negative 2 to the x? Negative 2 to the x versus g of x, which is 2 to the x. All right, let's do g of x first. What kind of function is this? Is this a polynomial function or is this an exponential function? Exponential. A polynomial function, your exponents are whole numbers. Here, your exponent is the variable. All right, so hence exponential. We're going to do this. We're going to do g of x first. What is your horizontal asymptote? Y equals 0. What is the domain? So if my domain is negative infinity to infinity, then that means that I can let x be 0, which means I'm finding the y-intercept. So let's do that first. I'm going to graph g of x equal 2 to the x. So let x be 0. And if x is 0, I get 2 to the first power, which is what? 2. Now I'm going to ask you this question. Based on what we discussed, is g of x an increasing function or a decreasing function?
Increasing.
Increasing, because the base is 2. 2 is bigger than 1. So you're going to notice that when I graph it, my y values are increasing rapidly. Oh, I'm sorry. I said to the first, right. That's what you're getting? Yeah, I'm not sure why I put 2 to the first. I have no idea. That should be 2 to what? 0, which is 1. Thank you. So 0, 1 is here. If x is 1, I get 2 to the first, which is 2. So 1, 2. If x is, let's say, 3, you just need a few points. If x is 3, I get 2 to the third, which is 8. So I get 3, 8, which is here. And then, guys, all you do is just graph it. You're done. Just make it look like an exponential, just like this. And on this side, what's happening on this side? Oh, I forgot to put the dotted line for the horizontal asymptote. Don't forget to do that. Don't forget to do the dotted line. So it gets closer and closer to the horizontal asymptote, and you're done. That is g of x equal 2 to the x. And notice the base is 2, the base is greater than 1, so it's an increasing function. What's the range? What's the range?
Oh, range.
0 to infinity. Parentheses. Y-intercept we found to be 0, 1, and this was an increasing function. Okay, now you're gonna get tripped on f of x. So if I ask you right away, f of x, is f of x going to be an increasing or decreasing function? Huh? Why decreasing? Because base is 2.
But it's a negative 2.
What is that negative? We talked about this before, so I'm just seeing how many of you remember this. What is that negative on the outside due to the graph? What's that word we use? Reflects it about the horizontal asymptote. So if that negative wasn't there, then yes, f of x would be what kind of function? Increasing. So it would be above the horizontal asymptote. That negative, remember, and we only did one, I think, but the negative, remember, is that reflection. So it takes that graph and reflects it about the horizontal asymptote. So now instead of, and we'll graph it, but now instead of increasing, it is doing what? Decreasing. So, okay, so I'm going to put the same shape over it, okay? And remember, we just said that negative does what? Reflects it about the horizontal asymptote, which in this case happens to be the x-axis. But is the x-axis always going to be the horizontal asymptote? No. So if I reflect it, though, when I do graph it, it's going to look like I'm trying to align my dotted horizontal asymptote. It's going to look like this. And it's going to be what? Decreasing. Okay? So it does help. It does help if you kind of visualize this in your mind, the idea of that reflection. So this is what we have right here. Trying to make sure it's aligned. And if I reflect it, I get this. Okay? All right, so let's go ahead and graph, though, f of x. So f of x is negative 2 to the x. All right, so watch how you can do this. Now remember, it does help if you understand what that negative does. So the negative is a reflection, so when you plot your points, you're going to actually see what it's doing. So if x is 0, always use 0 because you have to find the y-intercept. If x is 0, I get negative 2 to the 0. What is that? Negative 1, because 2 to the 0 is 1, and this becomes a negative 1. So I plot the point 0, negative 1. Which kind of makes sense because look, on g of x, wasn't a point 0, 1 on g of x? So if we're reflecting about the horizontal asymptote, it becomes 0, negative 1. So remember the idea of distances? This is the same as this distance. So this point is 1 unit above the horizontal asymptote, so this point has to be 1 unit below. This point is 2 units above the horizontal asymptote, so when I reflect it, it has to be 2 units below. This point is 8 units above the horizontal asymptote, so when I reflect it, it has to be 8 units below. All right? The idea of that symmetry. So I just need maybe 1 or 2 more points. So if x is 1, I get negative 2 to the first, which is what? Negative 2, which we already knew, right? And if x is, let's say, 2, I get negative 2 to the third, which is negative 8, which I already knew, because remember our discussion? If this point is 8 units above the horizontal asymptote, and I reflect it, it becomes 8 units what? Below. So this becomes, instead of 2, 8, it becomes 2 what? Negative 8. It's just like the discussion we had earlier with reflections, with symmetry, with the idea of that symmetry earlier. That same idea. So 2, negative 8. And then all I do is just draw my graph. Looks like this. And on this side, it gets closer and closer to the horizontal asymptote. And it kind of makes sense that needs to be the graph, because when I did this earlier, right here, and I reflected it, the red is going to overlap with the blue. Of course, I didn't draw it very well, but it should overlap with the blue. Okay? All right, so again, that's our second problem with that negative out in front, so the idea of that reflection. Okay, let's do a couple more. Oh, by the way, on this one, I forgot to finish this one. So in this one, what is the horizontal asymptote? Y equals 0. What is the domain? Negative infinity to infinity. All right, now, I'm going to ask you this. What's the range this time? Negative infinity to 0. Good. So the range is negative infinity to 0. So notice in some cases, it's not always 0 to infinity. It's not always the horizontal asymptote to infinity. It could be from negative infinity to the horizontal asymptote, depending on if the graph is above or the graph is below. So if there's a negative out in front, the graph will always be located where? Below the horizontal asymptote. Okay? What is the y-intercept? 0, -1. And is this an increasing or decreasing function? Decreasing. Notice is decreasing rapidly. See, my y values are getting smaller and smaller and smaller quickly. It's decreasing rapidly. So it's a decreasing function. So notice, if that negative wasn't there, it would be increasing. The fact the negative there is going to make it decreasing. All right, let's look at this one. All right, now, and we talked about this idea before as well. What if I had this, f of x equal 1/3 to the x minus 4. 1/3 to the x minus 4. What does that -4 do to the 1/3 to the x? It shifts it down 4. So that vertical translation. So instead of my horizontal asymptote being on the x-axis, or y equals 0, it's now going to be where? Y equals -4. All right, so what you're going to do is, first of all, you're going to tell me that the horizontal asymptote is y equal what? -4. And now you can also tell me whether this is an increasing or decreasing function. It's decreasing because my base is between 0 and what? 1. Notice I didn't strictly say less than 1. I didn't want to make that mistake. So you say between 0 and what? 1. All right, so it's going to be decreasing. And will it be above or below the horizontal? It will be below if there was a what?
Negative sign.
Reflection. Is this a reflection? No, there's no negative out in front. So it's going to be located where? Above. Okay? So it's a decreasing function. It's located above the horizontal. All right, so when I graph this, always make sure you draw your horizontal asymptote as a dotted line. So here's y equals -4. And all you do is just graph a few points, one of which has to be the what? The y-intercept. So if x is 0, I get 1/3 to the 0 minus 4, right? What's 1/3 to the 0? And what's 1 minus 4? -3. So I get the point 0, -3, which is right here. If x is, let's say, 1, if x is 1, I get 1/3 to the first minus 4. Use your calculator if you need to. You're probably going to have to, and it's okay if you tell me what it is as to the nearest tenth, but give it to me as a fraction if you can on your calculator. What's 1/3 minus 4? Which is, as a mixed number, is -3 and
3 2/3.
3 2/3. Which is -3.66666 on your calculator. So 1 -3 2/3 is about here, right? So you know right away, just on that point that I just plotted, you know right away that on the right side of that y-intercept, what is my graph doing? It's getting closer and closer to the horizontal asymptote. And so you know on this side is gonna shoot up like this. All right, so give me 2 points on the other side now. Just 2 is all I need. If x is, let's say, -1, use your calculator with that. I get 1/3 to the -1 minus 4. Now, 1/3, if you don't know this, if you don't remember this from a previous course, and you probably don't, because you don't really use this. You rarely ever use a number raised to negative power in real life. But what that negative does, if you want to make that exponent positive, remember, if you have a fraction raised to a negative exponent, and you want to make that exponent positive, in other words, you want to make it positive point, you just take the reciprocal of the fraction. So the reciprocal of 1/3 is what? 3. So 1/3 negative 1 becomes 3 to the first, which is 3. And if you put it in the calculator, you'll see that's what you get. So you get 3 minus 4, which is negative 1. So if you use your calculator to get negative 1, get negative 1. So I get the point negative 1, which is here. Let's do negative 2. Let's do our same discussion. I get 1/3 to the negative second power minus 4. Don't just calculate this just yet. You can, but this is what I want to say. I'm covering up the negative 4, so I'm looking at this fraction that's raised to negative power. One of the things you learned in the previous course when you dealt with negative exponents was that if I want to make that exponent positive, I take the reciprocal of the fraction, the base. What's the reciprocal of 1/3? 3. So it becomes 3 to the second power, which is 9. 9 minus 4 is 5. Now in your calculator, though, if you put in your calculator, you would say parentheses 1/3 raised to the negative second, and then subtract 4 and press enter. What do you get? 5. So negative 2/5 is here. And that's it. Just go ahead and draw the graph, and you're done. To do something like this. Okay? That's it. You're done, just like that. And so now you can answer some questions about this. Now remember, this was g of x equal 1/3 to the negative, 1/3 what? To the x minus 4. All right, so you can finish answering those questions. What is the range? What's the range?
0 to
Nope.
negative 4
-4
to
to what? Infinity. So the range, -4 to infinity. What's the domain? -infinity to infinity. It's all real numbers. What is the y-intercept? 0, -3. Good. What else did we talk about? Decreasing. So it's a decreasing function, right? Okay. Now, what if I had this? We're going to do one more. What if I had this? One-fourth. Let's call this g of x equal negative 1/4 to the x minus, let's do plus 3. G of x equals negative 1/4 to the x plus 3. A couple of things there. If I were to cover that negative, and you know that negative on the outside does what? That's the reflection. So the negative wasn't there. You all know that the graph better be located where? Above or below the horizontal asymptote? Above. The fact that there's a reflection, the graph will be located where? Below. And what is the horizontal asymptote? Y equals 3. Horizontal asymptote is y equals 3. Okay, so when I graph the horizontal asymptote, I'm going to have a dotted line like y equals 3. Just like this. And I'm going to ask you this question, though, and I want you to think about it. For probably only a handful at this point will be able to answer this question. is this function increasing or decreasing? Decreasing?
No, because it's a reflection.
All right, good. If there were no reflection, then it would be what?
Decreasing.
Decreasing. So in other words, it will look like this. I'm going to show you real quick using that transparency if I can find it. Although it's not the graph of it. But let's suppose that negative wasn't there. Then you said it was going to be decreasing, right? There's a reflection. What does it do? Reflects it, so now it's what? Increasing. Okay? So, when I asked you the question, is this function increasing or decreasing, not only do you need to look at the base, but you need to look and see if it's also doing what? A reflection. All right? Okay, so now, so we know that the horizontal asymptote is y equals 3, so I do my dotted line. What is the, so the horizontal asymptote is y equals 3. What is the domain? Okay. Since the domain's all real numbers, I can find the y-intercept. So you're going to let x be what? 0. So if x is 0, and listen carefully, if x is 0, you're going to say negative, in parentheses, 1/4 to what power? Plus 3. Now make sure if you're using your calculator, you do it correctly. You would have to put in on your calculator, you would say negative, parentheses, 1/4, close, raised to the 0, plus 3. But you can do this without the calculator. Because what's 1/4 to the 0? 1. So this becomes a negative what? 1. And what's negative 1 plus 3? 2. So my y-intercept is 0, 2. So I plot the point 0, 2, which is here. So now you see right away that that point is below. So where's the graph located, above or below? Below. All right, if x is, let's say, 1, I get negative, in parentheses, 1/4 to the first, plus 3. Now use your calculator if you need to. Negative 1/4 plus 3, if you use your calculator, and then write it back as a mixed number, is 2 3/4. Make sure you got that in your calculator now, okay? That's 2 3/4. So I get 1, 2 3/4 is 2 3/4. Right here. So you know right away what's happening to the right side of that y-intercept. My graph is getting closer and closer to the horizontal asymptote. Don't make it look like it crosses. You're going to be very upset with me. Don't make it cross, because you know that it's not supposed to cross the horizontal asymptote. And you know on this side is going to shoot down like this. All right, so pick 2 more points on that side and you're done. That's all you do. So give me an x value to the left of this y-intercept. Negative 2, okay? If x is negative 2, I get negative 1/4 to negative second plus 3. Now use your calculator if you need to, but listen to my words though. If I want this to be a positive 2, I take the reciprocal 1/4. What's reciprocal 1/4? So that becomes 4 squared, which is 16, but this becomes a negative 16, right? And what's negative 16 plus 3? Negative 13. So I plot the point negative 2, negative 13, which is negative 2, negative 13, which is here. And let's just do one more point that's between the negative 2 and the, I don't want to use negative 3 because then it would be way out of the plane. So let's just use negative 1. If x is negative 1, listen to I'm going to do this without using the calculator, so I need you to listen to me. Now, you can use your calculator, but listen to what if you don't have access to it. So if I want this exponent to be a positive 1, this 1/4 needs to become what? 4. So 4 to the first, but this becomes a what? -4. -4 plus 3 is a -1. Did you get that in your calculator? Okay. Make sure you can do it in your calculator as well now. So, -1 is here. Right here. So then you just connect your points. Just do the best you can. Something looks like this. All right, and you notice that it is an increasing function, and that's all you do. So this is the function g of x equal negative in parentheses 1/4 to the x plus 3. Okay. So it's not, when you practice with this, and we're almost done with this because we spent quite a few hours on this, quite a few days. So